Now we will find plastic modulus of some other T section. Hundred by 10 this is 200 by 10. So we need to find plastic modulus. For this T section. So now, as usual, we need to find first total area. Total area equal to 100 into 10 plus 10 into 200. So that equal to this 1000 and this 2000. Total 3000 mm square. So now half area. Half area equal to 3000 by 2, that equal to 1500 mm square. So now where the equilibrium axis will come? So see, this is 100 into 10,000. So we need to have another 500 mm square. That means this width is 10, and here somewhere here if it is 50 mm, now 50 into 10, this area will be 500 and this area will be 1000. So above the equilibrium axis, area will be 1500 and below the equilibrium axis, area will be 1500 because this is total 200, and if it is 50 here to here, then this will be 150. So 150 into 10, 1500 is the area below that equilibrium axis. So now ZP will be like this. So this rectangle area 100 into 10 and its entire distance is 10 by 2 plus 50. 10 by 2 plus 50 is the centroid distance. So its centroid is here to here. The distance is here to here 10 by 2 and here to here 50. So 10 by 2 plus 50 plus this area. 10 into 50 is the area into centroid distance is 50 by 2 plus below the equilibrium axis, the on rectangle is there, that is 10 into 150 into centroid distance is 150 by 2. Here to centroid, that is 150 by 2. So that equal to, so ZP will be 100 into 10 into 50 plus 5, that is 55 plus 10 into 50 into 50 by 2 makes 25 plus 10 into 150 into 150 by 2 means 75. So total 180 into 10 cube mm cube. This is the plastic modulus for this T section. So like this we can find plastic modulus for any kind of section. Now we will see plastic modulus for I section. So symmetrical I section we will see first. Let us take this as 200. This is 10. This is 100. This is 10. This is 200. This width is 10. We need to find plastic modulus. ZP. ZP. So first we need to split this section into two equal sub areas. So no need to calculate total area and all, because by seeing itself we can tell that equal area axis will be at 50 from this edge and or 50 from this edge, because of symmetry we can tell that. So now ZP equal to, first this rectangle 200 into 10 into centroid distance will be 10 by 2 plus 50 plus this portion of rectangle, that is 10 into 50 is the area, into 50 by 2 plus this portion, this also 10 into 50 into central distance is 50 by 2 plus finally bottom, this one, this flange 200 into 10 is the area, central distance is 50 plus 10 by 2. If you calculate, you get ZP as 200 into 10 into 50 plus 5, that is 55 plus 10 into 50 into 50 by 2 means 25 plus 10 into 50 into 50 by 2 means 25 plus 200 into 10 into 50 plus 10 by 2 means 55. You get 245 into 10 cube mm cube. This is the plastic modulus for this symmetrical I section. Now we will see some unsymmetrical I section about horizontal axis. Let us take this is 100, 10, this is 100, this width is 10, this is 20, and this is 150. Okay, now for this we need to find ZP, plastic modulus. Okay. First step, we need to find equal area axis. So for that we want to find first total area. Total area equal to, see here 100 into 10 plus this is also 10 into 100 plus this is 150 into 20. Total area 1000 plus 1000 plus 3000, total 5000 mm square. What is the half area? 5000 by 2, that is 2500. So clearly you can tell that equal area axis will be in bottom flange, because this is 1000 only, this is 1000, total together 2000 only, but we want area above equal area axis 2500, that means we need to get this as 500. That means 500 by width is this is 150. That means that 3.33. So this is 3.33 and this will be remaining 16.67. 16.67. So that is the equality axis. Now ZP equal to first top one, this one. 100 into 10 into standard distance is 10 by 2 plus 100 plus 3.33. Up to this, so standard distance is up to equality axis plus this rectangle 10 into 100 into 100 by 2 plus 3.33 plus this one 150 into 3.33 into 3.33 by 2. So this one, this area plus remaining bottom area, bottom flange area, bottom flange remaining area 150 into this is 16.67 into 16.67 by 2. That equal to, if you calculate that, this is 100 into 10 into this 105, that means 108.33 plus that is 1000, 10 into 100 is 1000 into this 50 plus 3.33, 53.33 plus this one 150 into 3.33 into 3.33 by 2 plus that one 150 into 16.67 into 16.67 by 2. That is 183.33 into 10 cube mm cube. So like that unsymmetrical sections also we can find plastic modulus. See here crucial thing is how to split this total section into two sub areas. So the equality axis should be such a way that the above that equality axis the area will be equal to below that equality axis. So two equal sub areas we need to split. So after that for every, here we have four rectangles. This is one rectangle, this is one rectangle, this above equality axis this is one small rectangle and below that this is one rectangle. So here totally four rectangles are there. For each and every rectangle we need to find the moment of area. See moment of area means, see 100 into 10 is area into standard distance, that is 10 by 2 plus 100 plus 3.33. Similarly plus 10 into 100 is the area of this rectangle and standard distance is 100 by 2 plus 3.33. Similarly same this one 150 is the width, 3.33 is the depth into 3.33 by 2 is the standard distance. Finally 150 is the width for this and 16.67 is the depth. So depth by 2 16.67 by 2 is the standard distance. So finally we got ZP as 183.33 into 10 cube mm cube. So for diamond shape we will find plastic modulus. This is diamond. This is 90 degrees each. Let us say this is A, for example. This is also A. So find plastic modulus. Now, so equality axis we can find easily because of symmetry. We can tell this is the equality axis. Equal area axis. So this is A means will be obviously a root 2, and this height will be a by root 2. Why here to here a root 2? Half of that is a by root 2. So for this, ZP will be like this. What is the area of this triangle? Half into base a root 2 into height is a by root 2. This is the area of this portion, and central distance is 1/3 of a by root 2. So for lower triangle also same. So no need to again write all these things. Just simply you can put 2 times of that. So that equal to here root to gets cancelled. A cube 2 3 6 and 6 means here 2 is there. This 2 cancel. 3 root 2. A cube by 3 root 2. Because a cube, this root 2 will go away. This 2 and this 2 will go away. So 3 root 2 will be there. So for diamond, plastic modulus is a cube by 3 root 2. Okay. Now, find for this. This is 100. This is 100. Plastic modulus. So answer will be like this. A cube by 3 root 2, that is 100 cube by 3 root 2, that equal to 100 cube by 3 root 2. 235.7 into 10 cube mm cube. This is mm. So like that you can find plastic modulus for diamond section. So now you can find plastic modulus for any section like rectangle, circle, T section, I section, symmetrical as well as unsymmetrical I sections, diamond section, triangular section, all these things. Now work out these problems. Find plastic modulus for following sections. Point 3, point 2. ZP equal to dash centimeter cube. This is 0.3 meters, 0.2 meters. ZP how many centimeter cube? Second problem. Circle of diameter 0.4 meter. ZP dash millimeter cube. Okay. Third one. Note down the third one. Third one. Triangle of 150 mm by 200 mm. ZP equal to dash mm cube. Fourth one. T section having 150 by 20 and this 100 by 10 mm, all are in mm. ZP equal to dash centimeter cube. Now, fifth one, fifth one, 250 by 20. This is 200. This is 20. This is 250. This width is 10. All are in mm. ZP equal to dash mm cube. All are in mm. Sixth one, diamond having diagonals 200 by 200 mm. Find ZP in mm cube. So solve all these problems. You'll get thorough in plastic modulus of any cross section. Okay, we'll meet in next lecture. Thank you.